Welcome, curious minds, to another deep dive from the Urban Herald team. Today we're unpacking a story that, well, it absolutely gripped the world last year. The OceanGate Titan submersible disaster. It was this harrowing search, wasn't it? And then the tragic outcome. It really laid bare a profound human and engineering tragedy. So our mission here is to go beyond just the headlines, pulling together critical findings from, official investigations, expert testimonies, even insights from recent documentaries. We want to give you a truly comprehensive understanding of what exactly went wrong.
Right, and it was June 18th, 2023, when the OceanGate Titan, which was very much an experimental submersible, imploded during its descent. It was heading down to the Titanic wreck site. Tragically, all 5 people aboard were killed instantly. This event, it marked the deadliest deep-sea tourism tragedy in almost a century, and it starkly exposed some critical systemic flaws.
Yeah, absolutely systemic. So let's really get into the nuts and bolts of it. We'll start by dissecting the Titan's design, which was highly controversial, even before the disaster. Then we'll move to that alarming pattern of ignored safety warnings, a really troubling history there. And finally, we'll look at the corporate culture, which tragically seemed to prioritize, well, innovation over established, proven safety protocols. And of course, the serious ethical questions this raises for extreme tourism, and the broader lessons, really crucial lessons this disaster offers for any high-stakes venture. Okay, let's unpack this.
Okay. So, to really understand why the Titan failed, we first need to grasp the basics of deep-sea submersible design. The forces involved are just immense. You see, these vessels have to withstand truly incredible pressures. As you go down, the pressure increases by roughly 1 atmosphere that's normal air pressure at sea level every 10 meters. Now, the Titanic wreck lies at nearly 4,000 meters. So down there, the pressure reaches, well, an astonishing 400 atmospheres.
400 atmospheres, that's hard to even picture.
It really is. Think of it like the weight of maybe 35 elephants pressing down on every single square inch of the vessel's hull. It's an unimaginable, crushing force, and that's precisely why traditional submersibles, the ones with decades of proven success, almost always use spherical titanium hulls.
Right, a sphere, because it distributes that pressure evenly.
Exactly. It's the ideal geometric shape to handle that kind of intense, uniform external pressure. It maximizes structural integrity. And look, this design isn't just a preference, it's really the result of decades of hard-won engineering knowledge, lessons learned, some of the hard way from past deep-sea explorations. It's tried and tested.
But OceanGate, this is where they made a critical, and as we now know, fatal deviation from those principles. The Titan, it didn't use a sphere. It used a cylindrical hull, and it was primarily made of carbon fiber with titanium hemispheres capping each end.
Yeah.
Here's where it gets really interesting. Now, carbon fiber, it's incredibly strong under tension, like when you pull it apart, but performs very poorly under compression when it's being squeezed.
That's the key weakness.
And it's also susceptible to fatigue, right? Especially with the kind of repeated cyclical pressures you get diving deep over and over again. The forces aren't constant.
Precisely. And that cyclical loading is brutal on composite materials like carbon fiber in a compressive environment. They can develop microscopic flaws that grow over time, eventually leading to catastrophic failure without much warning.
And then there was the join, the interface between the carbon fiber cylinder and those titanium end caps. That created potential failure points too, didn't it?
Absolutely. You have 2 very different materials bonded together. They expand and contract differently under the immense pressures and the significant temperature changes you find going from the surface to the deep ocean. This creates huge stresses right at that junction. It was a major concern highlighted by experts well before the disaster actually happened, a known vulnerability in this experimental setup.
Just incredible. And the Titan's own operational history, before the final dive, that should have been a huge red flag too.
Oh, definitely. The numbers are quite stark. Out of 87 previous dives attempted with the Titan, only 13 actually managed to reach the Titanic wreck site successfully.
Wait, only 13 out of 87? That's an 85% failure rate just to reach its target depth?
An 85% failure rate. Yeah, I mean, this wasn't just a bit of bad luck or minor teething problems. It clearly pointed to fundamental operational issues, perhaps even indicating the vessel wasn't really fit for purpose, certainly not reliable.
Wow. And then there's David Lockridge?
Ah, yes, David Lockridge. He was OceanGate's former director of marine operations. A crucial figure, really became a whistleblower. Back in January 2018, Lockridge submitted a very detailed engineering report, a safety report. In it, he outlined specific concerns about the Titan's structural integrity, the lack of proper testing, and critically, the use of carbon fiber, questioning if it was appropriate for this kind of deep-sea application.
So he's their own director of marine ops, handing them a report full of dire warnings. What did OceanGate do?
Well, what they did was, frankly, astounding. They fired Lockridge.
Fired him.
Yes. And then, perhaps even more shockingly, they initiated legal action against him. It really seemed like an attempt to silence his criticisms, to bury those concerns.
That just speaks volumes, doesn't it? About the kind of corporate culture they had. It sounds like reputation and pushing ahead were valued more than, well, actual safety.
It certainly points that way. And what's fascinating here is how this seems to go beyond just one person, like Lockridge, or one single incident. The dismissal of his expert concerns suggests really systemic problems within OceanGate safety culture. The leadership, particularly CEO Stockton Rush, consistently seemed to prioritize perceived innovation and, let's be frank, cost reduction over established proven safety practices.
Right.
This is a classic example of something called normalization of deviance. It's a concept from sociology.
Normalization of deviance. How does that work?
Yeah. Well, basically, risky practices or cutting corners become accepted over time. Each time they completed a dive, even if there were issues, maybe a strange noise, a communication drop, a system glitch, it subtly reinforced a false sense of security. The thinking becomes, well, it worked okay last time, or we got away with it, and gradually those critical safety margins, the things that should be absolutely non-negotiable, they just get eroded. Danger becomes the new normal.
Chilling. And it wasn't just internal warnings they were ignoring, was it? There were external experts raising alarms, too.
No, not at all. Prominent figures, people with serious credibility in deep-sea exploration. You had filmmaker James Cameron, who's dived to the Titanic himself many, many times and knows the deep ocean environment incredibly well.
Yeah, he was very vocal afterwards.
And he was. And submersible expert Rob McCallum, another respected voice, they both publicly criticized the Titan's unconventional design, its use of carbon fiber, and especially its alarming lack of independent certification. But again, OceanGate's leadership, particularly Rush, seemed to dismiss these warnings. They framed it as resistance to innovation, as established players trying to stifle a disruptive newcomer.
That lack of certification seems absolutely key here.
It is absolutely critical. You see, independent certification by established classification societies, organizations like the American Bureau of Shipping, ABS, or Det Norsk Veritas, DNV, it's the cornerstone of maritime safety. These bodies ensure vessels meet incredibly stringent safety standards through comprehensive design reviews, material testing, construction oversight, and rigorous sea trials. They rely on decades of data and proven engineering principles.
But OceanGate decided to skip that.
They made the deliberate decision to self-certify the Titan, to essentially bypass these established, internationally recognized maritime safety protocols entirely. CEO Stockton Rush publicly argued that existing regulations were outdated and stifled innovation. But, this approach proved tragically flawed. The very standards they ignored were put in place specifically to prevent the kind of catastrophic structural failure that ultimately destroyed the Titan.
And their own testing didn't measure up either, right?
Not by established standards, no. For instance, a standard certification process typically requires proof testing a submersible hull to at least 1.5 times its maximum operation pressure to demonstrate a safety margin. From what we know, OceanGate's testing program fell far short of such critical benchmarks. There were reports of incomplete pressure testing, potential issues with non-destructive testing methods for the carbon fiber, and maybe inadequate material characterization for that specific application.
And this is where the regulatory gaps come in, particularly in international waters.
Exactly. The disaster really threw a harsh spotlight on significant regulatory loopholes. Because the Titan operated primarily in international waters, OceanGate was able to exploit certain ambiguities in maritime law. This allowed them to circumvent safety requirements, like mandatory certification, that would likely have been enforced if they operated solely within a single nation's territorial waters. Essentially, they found a gray area to operate their uncertified vessel with paying passengers.
Which brings us to the passengers, paying a huge amount of money, $250,000 each, for this trip.
$250,000 per person, yes. It targeted ultra-high net worth individuals seeking a unique, extreme experience. And critics argue this created potentially perverse incentives. The focus might have shifted towards maximizing profit and selling these exclusive tickets, possibly overshadowing fundamental safety considerations. It raises serious ethical questions.
It really does.
This raises an important question, doesn't it? What exactly are the ethical responsibilities of companies offering extreme tourism like this? You could argue they have significantly heightened obligations because of the huge information asymmetry. The clients, even wealthy and intelligent ones, they lack the specialized knowledge to truly assess the risks involved. They are completely reliant on the operator's expertise and judgment regarding safety.
They have to trust the company.
They have to trust them. And the Titan disaster is just a tragic illustration of what can happen when that trust is misplaced, when operators appear to prioritize commercial goals or perceived innovation over passenger safety, continuing operations despite knowing about serious, unresolved technical concerns.
And for the people taking these trips, there's a certain psychology at play too, isn't there? This elite risk-taking mindset.
There definitely is. For some participants in extreme tourism, you see phenomena like the overview effect, that sense of awe and perspective shift, often talked about by astronauts. Or maybe it's simply the pursuit of truly unique, exclusive experiences that very few people can access. These powerful motivators can sometimes override a purely rational assessment of the risks involved. It might lead individuals to accept dangers they might otherwise avoid, especially when it's packaged as a cutting-edge premium experience by a company that seems confident and innovative.
Confidence, maybe bordering on overconfidence.
Well, that's another psychological factor we need to consider, particularly regarding the leadership. Stockton Rush's approach seems to exhibit what psychologists call overconfidence bias. This is where initial successes, even if those successes were perhaps lucky or flawed, can reinforce belief in one's own judgment in controversial decisions. It can lead to downplaying risks and dismissing warnings. We've seen this pattern in other major technological failures throughout history, where a leader's strong conviction unfortunately blinds them to critical flaws.
And inside the company, did groupthink play a role?
It very likely did. Groupthink is where the desire for harmony or conformity within a group results in an irrational or dysfunctional decision-making outcome. Within OceanGate's internal culture, it appears that critical evaluation of safety concerns may have been suppressed. Dissenting voices like David Lockridge's were marginalized or even pushed out. If someone did raise a red flag, say about a strange noise or a test result, the pressure to maintain the company's innovative image, or maybe just the push to meet demanding dive schedules, might have led to that concern being minimized or explained away by the group. This kind of environment prevents the rigorous, objective safety analysis that was absolutely essential for something as inherently dangerous as the Titan.
It all paints such a concerning picture. And the recent Netflix documentary, Titan, the OceanGate submersible disaster from 2024, really brought many of these elements together for a wider audience, didn't it?
It absolutely did. It's a powerful piece of filmmaking. Directed by Ava Marie, it serves as a really pivotal piece in the public understanding of this whole tragedy.
What were its main strengths, do you think?
Well, it has a gripping narrative structure, first off. It manages to build tension effectively, even though we know the outcome. Crucially, it provides excellent access to key figures, especially whistleblowers like David Lockridge. Hearing his story firsthand is incredibly impactful. It also does a commendable job of explaining the complex technical failures in a way that's clear and digestible for a general audience. And importantly, it never loses sight of the human element, the 5 lives lost, powerfully highlighting that warnings ignored narrative we've been discussing.
Yeah, the human cost is central.
And the production quality itself is very high, as you'd expect from a major Netflix documentary. The visuals are compelling. They use archival footage effectively, alongside graphics that really help explain the physics and engineering involved, the immense pressures. The sound design contributes a lot, too, creating an almost claustrophobic atmosphere at times. And the interviews, they're the backbone, insightful perspectives from various experts, and as I said, those particularly poignant accounts from the whistleblowers. It makes the technical accessible and the human tragedy palpable.
So taking all this and the design flaws, the ignored warnings, the culture, the documentary's portrayal, what does this all mean? What are the big lessons learned moving forward? This disaster has to spur change, right?
It absolutely has to. And it is spurring calls for fundamental reforms across the entire submersible industry and beyond.
Okay, so starting with engineering and design.
The primary lesson there is crystal clear. Innovative materials and novel designs, especially for life support systems in extreme environments, they must undergo exhaustive, rigorous validation before they are ever used in passenger-carrying operations. Full stop. The Titan disaster unequivocally demonstrated that the type of carbon fiber used, while strong in aerospace applications under tension, is fundamentally unsuitable for the immense cyclical compressive loads found in the deep sea. Future submersible designs simply have to prioritize proven materials like titanium or specialized steel and proven geometries like spheres over unvalidated experimental approaches when human lives are at stake.
And regulation and certification. Those loopholes need closing.
Urgently. The disaster has ignited extensive discussions about precisely that. Proposed changes include making third-party certification by recognized classification societies mandatory for all passenger-carrying submersibles. And critically, this needs to apply regardless of where they operate, closing those international waters loopholes. There's also a clear need for much stronger international cooperation to create and enforce harmonized safety standards. We can't have operators jurisdiction shopping to find the weakest oversight.
That makes sense. And what about the industry culture, the safety management side of things?
That's arguably just as important. The Titan tragedy underscores the absolute necessity of fostering a robust safety culture within any organization involved in high-risk activities. Key lessons emphasize creating structures that actively encourage and protect whistleblowers, people who raise safety concerns. Implementing truly rigorous independent safety oversight is crucial. Empowering independent safety committees or personnel to have the authority to halt operations immediately when serious concerns arise. And perhaps most fundamentally, establishing a very clear, bright line between experiment R&D and operational passenger service. You simply cannot treat paying passengers like test pilots for unproven technology.
It sounds like common sense, but clearly it wasn't applied here.
Sadly not. And when you look back, you can draw some compelling comparisons to other major disasters where similar factors were at play.
Like the original Titanic.
Exactly. The Titanic disaster back in 1912 involved a dangerous overconfidence in the technology of the ship, famously deemed unsinkable, combined with tragically inadequate safety provisions like the number of lifeboats.
Okay. Any others?
Well, more recently, the Costa Concordia cruise ship capsizing in 2012. That showed a deliberate deviation from established safety protocols, apparently for commercial reasons, the captain performing a risky maneuver close to shore. And perhaps one of the most chilling parallels is the Space Shuttle Challenger disaster in 1986. That's a textbook case of the normalization of deviance we talked about. Engineers had known about problems with the O-rings in cold weather, but warning signs were repeatedly dismissed or rationalized away by NASA leadership under pressure to maintain launch schedules. Until disaster struck.
Wow. It's quite a pattern.
It is. What's truly striking across these very different disasters, a ship, a cruise liner, a space shuttle, a submersible, is that common thread. It's often a dangerous mix of organizational issues, like poor communication or pressure to perform, psychological factors like overconfidence bias or groupthink, and this gradual erosion of safety margins. It's a toxic combination that, time and again, leads to preventable catastrophe.
So to wrap this up, the OceanGate Titan disaster, fundamentally preventable.
Yeah. Unequivocally, it was a preventable tragedy, stemming from this devastating intersection of, you could call it, engineering hubris, significant regulatory gaps, and what appears to be profound corporate negligence. As we've detailed, the submersible's flawed design, that alarming pattern of ignored warnings from both inside and outside the company, and the normalization of risky practices within OceanGate's culture, they all combined. They created conditions where a catastrophic failure wasn't just possible, it was, sadly, almost inevitable.
And the lessons here, they really go far beyond just submersibles, don't they?
Absolutely. They touch on much broader, critical questions about the inherent dangers in the growing market for extreme tourism, the absolute necessity for robust, independent oversight in any high-risk field, and fundamental corporate responsibility when dealing with human lives. We at the Urban Herald believe these are vital lessons for any industry pushing boundaries anywhere in the world. And as the official investigations continue, and hopefully safety protocols are genuinely strengthened across the maritime world and maybe in other extreme industries too, the memory of those 5 individuals who lost their lives aboard the Titan Stockton Rush, Hamish Harding, Paul-Henri Nargeolet, Shahzada Dawood, and Suleiman Dawood, their memory must serve as an unwavering catalyst for meaningful, lasting reform. The path forward demands an absolute non-negotiable commitment to prioritizing safety over the allure of innovation, transparency over secrecy, and proven engineering practices over unvalidated experimental shortcuts.
So a final thought for you, our listeners, to mull over as you reflect on this deeply concerning story. What does the Titan disaster ultimately teach us about the true cost of unchecked innovation when safety isn't the absolute priority in any field? And perhaps more personally, where do you draw the line between groundbreaking exploration, which we need, and reckless disregard for fundamental safety? Something to think about. We really appreciate you diving deep with the Urban Herald team today.